So Gay-Lussac's law states that the pressure of a gas of a fixed mass and a fixed volume is directly proportional to the gas's absolute temperature. So just think about this a little bit intuitively, why this would happen. It's pretty obvious. When your temperature goes up, your kinetic energy goes up. That's something that we've learned this year. When the kinetic energy goes up, the particles of the gas would be colliding with the container more often, which would cause the pressure, therefore, of the gas to go up. So this whole law sort of makes sense, and it applies directly to what we did. So what Gay-Lussac was able to do is come up with this formula. So for the same substance over two sets of conditions, the initial pressure over the initial temperature equals the final pressure over the final temperature. In this experiment, we use the pressure in atmospheres and the temperature in degrees Celsius. Alright, ready? So we followed the following procedure for our experiment. First, we started off with the empty glass bottle, which had the same temperature and the same pressure as outside. So we used the internet to find out that the temperature outside was 28.33 degrees Celsius and that the atmospheric pressure was 1.002 atmospheres. Next, we added in boiling water into the bottle, and then we emptied out the boiling water. So the water was at 100 degrees Celsius, and we're assuming that after we filled it up and we emptied it out, some heat was lost, but overall, when we measured, we had about 97 degrees Celsius for inside the bottle. So because of what we know about gases, at a higher temperature, they have a higher pressure. So at this point, we had a higher temperature than what it was before, and we also have a higher pressure. Next, we performed our experiment. We had the empty bottle, which was now capped at the top with our siphoning device. Then we put it into a cup with ice cold water and saw that a vacuum was created that pulled up the water from the cup on the bottom into the actual bottle. So basically the water was sucked in by the vacuum. The reason that this happened was because the bottle wanted to reach equilibrium with the pressure outside. Because we concluded that the pressure inside the bottle was much higher than the pressure outside, by sucking in the water, the bottle was able to reach a lower pressure and meet pressure and have the same pressure as what was outside. So pretty wow overall. So this is how Gay-Lussac's law sort of applies to our experiment and how we can use real empirical data to back up what we found observationally. So we have here the formula, the initial pressure over the initial temperature equals the final pressure over the final temperature. So the initial pressure that we found online was 1.002 atmospheres. The initial temperature was 28.33 degrees Celsius. So, an average day outside in Florida. The final temperature, which was the temperature after the bottle was filled and empty with that hot water, that boiling water, was 97 degrees Celsius. Now the pressure, the final pressure inside of that bottle is what we're trying to find, and that's exactly what we used with Gay-Lussac's formula. So we went ahead and set up this formula, put everything into its respective place, and then we solved for x here, which is our final pressure. And what we were able to find was that it had a final pressure of 3.43 atmospheres. So if we compare that to our initial pressure, we had an initial pressure of 1.002 atmospheres, and it went all the way up to 3.43 atmospheres. So as we saw in our experiment, the bottle sucked up water so that it could reach the outside pressure of 1.002 from 3.43.